We now start learning how to solve linear inequalities, and we're going to do so by working through the two examples that we have here. So let's go right ahead and get started. In this first example, we need to solve x plus 3 less than 1. Now remember that an inequality is a statement which is either true or false. So when we refer to solving an inequality, like the one here, we mean finding the values of x for which this statement is true. And the trick behind solving an inequality like the one we have here is to isolate the x. In other words, we want to make sure that x is on its own on one side of this inequality. And to do that, we're going to use inverse operations. So let's see how that works. We have to solve x plus 3 less than 1. Looking at the left-hand side here, we can see that 3 is being added to x. So to get rid of that 3, we can do the inverse of adding 3, which would be subtracting 3. So we're going to subtract 3 from the left-hand side. But if we subtract 3 from the left-hand side of the inequality, we have to do the same on the right-hand side. So we're going to subtract 3 on the right-hand side as well. Now on the left-hand side, we have x plus 3 minus 3, which leaves us with x. On the right-hand side, however, we have 1 minus 3, which is negative 2. And that's the answer. We've just solved this inequality. And this solution is telling us that if x is less than negative 2, then x plus 3 will be less than 1. Now, at times, we'll also be asked to illustrate this solution on a number line. And here's how to do that. We start by drawing a number line, something looking like this, and say I have a 0 here, negative 1 here, negative 2, negative 3, and so on. To illustrate x less than negative 2, we start by placing an empty dot above the negative 2, followed by an arrow pointing towards all the numbers less than negative 2. Notice that the dot above negative 2 is empty, and this is to highlight the fact that x cannot be equal to negative 2. And there we have it. Okay, let's look at the next example. Here we need to solve x minus 2 greater than or equal to 3. Well, once more, to solve this inequality, we're going to use inverse operations. We can see here on the left-hand side that 2 is being subtracted from x. So to get rid of this 2, we're going to do the inverse of that. And the inverse of subtracting 2 is to add 2. So we add 2 on the left-hand side. But since we're adding 2 on the left-hand side, we have to do the same on the right-hand side. So the left-hand side becomes x minus 2 plus 2, which leaves us with x, and on the right-hand side we have 3 plus 2, which leads to 5. And we're done. And this solution tells us that so long as x is greater than or equal to 5, the expression x minus 2 will be greater than or equal than 3. And just as in the previous example, we can illustrate this solution on the number line. So again, we draw a number line, something like this, and say 0 is here. We'll have negative 1, negative 2, 1, 2, and so on. To illustrate x greater than or equal to 5, we place a dot above the 5, but in this case, we fill in the dot. And we draw an arrow pointing towards all the numbers which are greater than 5. Notice that in this case, we filled in the dot. That's to highlight the fact that here, x can be equal to 5. And there we go. That's the end of our first tutorial on solving linear inequalities.